Today's lesson is lesson 78, found on page 510, which is graphing rational functions. So far we've been graphing linear equations. Linear equations are the form y equals mx plus b. It is an equation that represents a line, where b represents the y-intercept and m represents the slope. So if we have y equals 2/3 x plus 2, in order to graph this equation, we would first start at the y-intercept, which is at positive 2, put our first point, and then use our slope to find our second point. We rise 2 and run 3 to find our second point. Connecting those two, we graph the line that is a linear equation. Today we're moving into the rational functions. A rational function is a fraction with a variable in the denominator of the fraction. And as we've been learning, if I have a variable in the denominator of the fraction, then I have restrictions on what that variable can be. Let's remind ourselves what we've been learning with regards to the fractions and the variables at the bottom. In previous assignments, we've been given expressions that look like this, and we've been asked to find the restricted value. The restricted value is where the denominator can never equal 0. So to find that value, I would simply take the denominator and set it equal to 0 and solve. Solving the equation, I would first move the 30 over with opposite operations by subtracting 30. I get 5a is equal to negative 30. I continue by dividing 5 on both sides to get a is equal to negative 6. That is the restricted value of this expression. We're going to be using this today in graphing the rational functions. A rational function is something that looks like this. Y equals 1 over x. Again, with a variable in the denominator of the fraction. This is one of the easier sorts of rational expressions. We'll also be looking at things like this. Y equals 5 over x minus 3. And finally, we'll look at the examples. Y equals 8 over x minus 4 plus 2. Examples of this sort. To graph rational functions, you need to understand asymptotes. An asymptote is an imaginary line that is in the xy coordinate system that a function never comes in contact with. If I am looking at the rational function y equals 1 over x, and I'm attempting to graph this on my xy coordinate system, I would use ordered pairs to get started. There's my x values and there's my y values. Y could never equal 0. X could never equal 0. Y could never equal 0. I could never put 0 at the denominator of my fraction. So x can never equal 0, and if x can never equal 0, then y can never equal 0. So my asymptotes are the axis in these problems. Those are actually my asymptotes. My graph will never come in contact with those lines. Let's pick some points and see what I'm speaking of here. Let's let x equal 1. If x is equal to 1, 1 over 1, y is also equal to 1. If x is equal to 2, then I have 1 over 2, which is a half. If x is equal to 3, then this would equal 1/3. Now, if x is equal to the fraction 1/3, then y is going to equal to 3. Because what I have is 1 over 1/3, which is 1 divided by 1/3. Skip, flip, and multiply makes me go 1 times 3, which is 3. So if I have 1/7, then my y value will be 7. The negative values are exactly the same as the positive values in this case. If I let x equal a negative 1, y would also equal a negative 1. If I let x equal negative 2, y would equal negative 1/2. If I let x equal negative 3, y would equal negative 1/3. And if I let x equal negative 1/3, then y will equal a negative 3. If I let x equal negative 1/7, y will equal negative 7. I then take these scattered points here and put them on my graph. 1, 1, 2, 1/2, 3, 1/3, 1/3, 3, 1/7, 7, all the way up there. It will increasingly go up, but never come in contact with either one of those axes. It will never come in contact with the x-axis, nor will it come in contact with the y-axis. This, which is in the first quadrant, is repeated here in the third quadrant. They look very similar, doing the same thing. Negative 1, negative 1, negative 2, negative 1/2, and so on. Those are called the asymptotes, the lines that will never be touched when we're graphing rational expressions. Those asymptotes happen sometimes with the restricted values of the function. If I'm looking at the rational function, which is y equals 3 over x minus 2, then I look at the denominator. The denominator is going to get me the vertical asymptote. So I say y minus 2 equals to 0. Split at the equal sign, adding 2 to both sides. X can never equal 2. Therefore, my vertical asymptote is x is equal to 2. My horizontal